We specifically focused on optimizing this to run on relatively cheap hardware. If only one person can feasibly operate the prover instance, it's still centralized. We want this full system to be decentralized. We're getting close to a world where a user can actually self-relay as well for valuable transfers. Because for example, Ethereum is technically two chains, the beacon chain and the execution chain. So now the relayer needs to start handling this. And this is of course not a fundamental theoretical CS problem, this is just an engineering problem.
Welcome to the Bare Metal Podcast.
Hello everybody, and thanks for tuning back into the Bare Metal Podcast. This is Ship the Code from Rockaway X Labs. Today here with Karel. Welcome.
Yeah, happy to be here.
So Karel, super excited to have you on. You are part of Project Union. I'd love to hear all about it. Can you begin by giving us a short intro to yourself, and then how did you get to start Union?
Yes, I'm the founder of Union, but a systems engineer by background. So previously I worked a lot in the Polkadot space, doing the first trustless bridge between Polkadot and Kusama and Polkadot and Osmosis, based on consensus verification. Besides that, I've been in crypto since about 2015-ish, initially working in the Ethereum Solidity space. And even back then, believing that we were going to go to a world of many different blockchains instead of just one single blockchain that has all of the apps on it. And that's what originally spiked my interest in interoperability because it's so reminiscent of the early internet.
So what is Union? Like, how would you describe the company and the product?
Yeah, so initially a very much research-focused company on doing zero-knowledge technology. So mainly focused around building light clients and using ZKPs to scale that compute off-chain with the goal of accomplishing really fast and really secure bridging data transfers between different L1s and L2s.
So did you guys, when you say you guys did research into ZK and light clients, do you guys modify any sort of ZK proving schemes, or did you sort of apply those schemes to say block header verification or transaction inclusion?
Yeah, so we mainly apply existing schemes. We do have some internal forks of NARC, for example, with some performance optimizations in there. And fundamentally, indeed, look at different consensus models, make circuits out of those, try to do it as efficiently as we can. On top of that, so a light client really only tracks another chain, right? But if you're doing a specific bridging protocol, you can basically put part of that bridging protocol in the circuits as well, and that saves you more gas costs. In the end, you get a more efficient protocol if you basically have product-specific optimizations baked into your ZK stack.
Right. So let's go back to sort of to Union proper. What is the product that you guys built, and who are you working with? What does it do today?
Yeah, so we were very much focused around ZK-IBC. So initial products that we've built is right now the most performant IBC implementation on Ethereum. We support Scroll at the moment. We're working with Movement Labs on supporting all of their L2s. Right now looking at optimistic L2s as well, and potentially integrating Polygon's egg layer. So really the goal is get IBC integrated everywhere. And then the special sauce is, can you do it efficiently enough to do it in new ecosystems where there's no native support for this, right? Can you make it cost competitive with existing solutions?
And how does so that's like a 10,000 foot level view, right? But it's still in my head, it's very hard to break down how these things work. Now looking at your website, I did a skim, there are different components you guys mentioned. There's Scala, there's Comet BLS, Voyager. How do these things hang together? What do the pieces do?
Yeah. So for those that were more familiar with IBC, there are already existing toolings, existing stacks for IBC between different Cosmos SDK based chains. The first challenge that you get is, to be honest, a real engineering challenge, which is these existing tools don't support new ecosystems. They don't support the EVM, ETH API, those RPCs, etc. So Voyager is our in-house relayer to deal with these new ecosystems. And as it so happens, some of those ecosystems are a lot harder to support because, for example, Ethereum is technically two chains, the beacon chain and the execution chain. So now the relayer needs to start handling this. And this is, of course, not a fundamental theoretical CS problem. This is just an engineering problem, right? Kind of a DevOps challenge. And so for that, we wrote Voyager to handle that gracefully. Then Comet BLS is our modified version of Comet BFT to make it more efficient for provability. And you get some massive performance gains with this. Right now, compared to, for example, Tendermint X, proving times are about 6 seconds, which means that latency of bridging from a Cosmos chain into another chain is about 12 seconds in total, which compared to, for example, what we're used to in bridging right now, it's actually extremely fast. Galois is the zero knowledge, the prover, basically the machine that generates proofs for this. Initially, Galois required about 32 cores, 32 gigabytes of RAM to operate, so quite compute intensive. And it was the early days of Union. We specifically focused on optimizing this to run on relatively cheap hardware. And the reason for this is, even though a ZK system is fundamentally quite sound and secure, if only one person can feasibly operate the prover instance, it's still centralized, and your bus factor is 1. And so one of the core foci we had for Union was we want this full system to be decentralized, in the sense that hundreds of infrastructure providers could participate, potentially even end users, right? Can you actually generate a ZKP on a MacBook M2? That was a big priority for us.
On a device. Super interested, if you think about having many provers, just focusing on the Galois component there for a sec, how would you organize the sort of proving marketplace, or the permissionless nature of the proving? Would there be a sort of market which connects guys who supply proofs to proof demand from, say, Comet BLS? Or because it seems to be a challenge in these how do not waste computational power, be efficient, but yet have censorship resistant properties and sort of speed for good user UX.
Yeah. So we've taken quite a pragmatic approach here. The way I see it, and to make this work for IBC, right, is to pay the party that performs the transaction, that does the settlement, a large portion of the fee. Because if you do that, then you create a truly valuable market around it. IBC does somewhere around 3 billion to 4 billion a month. To monetize that for the relayers is what makes this a resilient system. Relayers, right now it's kind of a little bit common good, right? They run it for a specific chain and they announce that they perform this service for this chain. Really what you want is to create a system where they start competing with each other, where someone from the outside looks at relaying and thinks, oh, that's a really good deal, right? I'm going to run one myself because you can make a lot of money on this. That's what you see in MEV right now. So if you take an example of MEV, how do we make relaying like MEV? That's by paying the transaction fee to the relayer, and then they start racing for proof generation, right? Because if you generate proofs in 8 seconds and I generate them in 6 seconds, that's quite trivial for me to basically completely outcompete you and settle all of those transfers. Now, if you have a market that operates at that's a fair self-optimizing market, because now you are incentivized to buy better hardware or fork the code and do an optimization yourself. And that's when you can start looking at these different proving markets, right? Because instead of it being just a partnership, we start evaluating these proving markets on how efficient are they. If a proving market is 30% faster than another one, it will automatically start dominating, right? Because that's how you capture most of the order flow value. And I think in general, these types of systems are the ones that are most resilient. Those kind of become self-sustaining and build out ecosystems on top.
I'm really curious. I see one weakness there, where if it's the winner takes all approach, that's my term for it. So the fastest prover, the only one gets paid. I'm wondering if that leads to the centralization. We'll have a similar situation like with Bitcoin miners, right? Then you buy better ASICs, and then only well-capitalized players can be fastest. And since they take most of the proof income, they're the only ones who can do that. Like in relaying, there's a very similar problem today, right? Whereas if you think about, blockchain projects wonder how many relayers should I support to connect a channel between two chains? Because you don't want to always be paying only the first one in, because you need to have that second and third backup. So maybe is there some sort of weighted distribution between the first K, where K can be a number you pick for security, but then you do accept that you're wasting some of your funds, or one way to think about it would be wasting, but I don't think you are. So I'm wondering, have you guys considered this aspect, or do you want to somehow smooth out the rewards?
Yeah, so the way we felt about it is by potentially designing it to split the work up into two functionalities. So rewarding provers separately from relayers and using, for example, Celestia to store proving data itself. That way, at least like a large part of the expensive compute is incentivized separately. And then you can have a potential mechanism where indeed there is a schema where provers take a turn, for example, to generate one of these proofs and have a fallback mechanism. I think at the relaying level, it's hard to have a resilient system that rewards multiple relayers at the same time. One thing that I think is important to note here is kind of with like account abstraction and paymasters, we're getting close to a world where a user can actually self-relay as well for valuable transfers. So even if you have basically centralization of relaying itself, it's trivial for people to spin up a new relayer and start participating. So if one of the relayers drops out, there's an opportunity for someone else to make money. And as a fallback, a user can always self-relay, generate a ZKP on the laptop and send that forward. Might on the MacBook M2 for Union right now take about 15 seconds in the browser to generate a ZKP and forward that. But yeah, these are hard issues, by the way. More philosophically, like I went into crypto not necessarily because it's a communist utopia, but mainly because it's a meritocracy, right? You do always find like centralization of basically the people that are the best at a certain functionality, and that way take domination.
Yeah, I mean, I would agree. The way the where this sort of impacts, I'd say that the crypto ideals is on the potential for censorship resistance. Like if you have too few strong parties, I guess that's the only counterbalance. Even if you think of it from sort of like a meritocratic perspective, I feel like that's what most people are worried about, including myself. So we spent time on Galois as the prover and then the construction market around it. Like, do you guys have clients up? If I'm running, Galois, can I just run separately like a process that just computes proofs and supplies them to the network?
Yeah, it's basically a gRPC server that just serves proofs to your relayer. So you can choose to put it on a different machine, and you can choose to share that between different relaying instances. Someone could decide to just kind of serve this to whomever. So we, for example, work together with parties like Sysig to at some point have custom hardware for this as well. So you might see that there's basically a SaaS. They just extremely fast generates proofs for a few cents per proof that relayers can call into. So they don't need to run that hardware specifically.
Right. And so Comet BLS aggregatable signatures, is that where the BLS is coming from?
Yeah, exactly. There's a few other optimizations in there as well with regards to the different trees that are used, for example, to store the packets when we do packet inclusion proofs. But there's also BLS signature aggregation in there. Basically, it's just a take on Comet BFT and optimizing it as much as we can for bridging purposes to get kind of the cheapest possible proof verification. Because in the end, if you want to do IBC towards Ethereum, you're fighting against gas cost, right? You can be spending 5 million gas to do a light balance update.
Right. And what, just as a point of interest, do you know off the top of your head what Comet BFT version you guys branched off of to build Comet BLS? Was it like 0.38 or 0.34?
I'd need to check. We've kept it up to date for now. So I think right now we're on the latest version again. We're looking to actually upstream this at some point, but obviously now there's a bit of refactoring work going on to modularize everything. But most of the improvements will probably be available through vote extensions.
Mm-hmm. Mm-hmm. So yeah, right. So that be 0.38 is I think where vote extensions were introduced. That's what DYDX is using, and I think Berachain is being built on. So we haven't hit the third one. So what's Voyager?
Yeah, so Voyager is our own relayer, kind of a technical competitor to Hermes, written in Rust as well. For the developers here, it's basically message-based. So it uses a message queue in default configuration Postgres to store whatever it is processing, whatever it's doing, and can support many chains at the same time. For us, like dealing, for example, with only relaying to Ethereum, it was already quite hard to debug everything because it has to fetch data from not just 2 chains, but 3 chains. On Ethereum, you don't have single slot finality. So when you look at a block, you're not sure if that block is finalized yet, right? So you need to deal with reorgs, data suddenly disappearing. And so Voyager encapsulates all of that effort. We've been running it right now for about 6 months in testnet, non-stop. And currently they're actually working on Tendermint to Tendermint relay. So it'll be a new type of relayer that people can use.
In among the chains of the Cosmos ecosystem.
Yeah.
And is there, so you mentioned Ethereum, you mentioned Tendermint, any other sort of ecosystems, like any links to Polkadot or Avalanche or
Yes, so Avalanche, we've been working on the designs for that and talking with Ava Labs, but they're doing a re-architecture of their P chain, so their consensus is changing. So at the moment, it's actually, if you're going to put work in it right now, not really worth it, because all of that work is going to be deprecated relatively soon. So we have scroll support in there as well. So for ZK EVMs settling on Ethereum are supported. And now we are targeting Arbitrum and the Orbit ecosystem. So different L3s. And there, once again, kind of you see how this becomes more complex, because you're not just tracking the L3 itself, but you're tracking the L2 and Ethereum
and
to
settlement
support this.
Yeah, that's when these trust assumptions become really complicated, right? Like, when do you believe the state on the L3? Yeah, that sounds like so. So the key differences between Hermes and Voyager would be, like, just going back up, support for multiple other sort of chain types instead of just Tendermint, or consensus types, what we call it, instead of just Tendermint, which Hermes focuses on.
Yeah, and Voyager internally is transactional. So every single I/O request, like data it fetches from a chain or a transaction it submits, goes through a queue that it stores in Postgres, which makes it a lot easier to debug overall with what's going on in complex situations, in reorgs, etc. And it allows for really nice dashboarding to see what it's doing internally.
And what do you guys think about the economic reality of relaying? And are you guys trying to resolve this somehow, where relayers mostly, as you said, a little bit of a public good? I think most operators would say, well, entirely public good. Like, you need to ask someone to basically cover your transaction costs. There were ideas around, the user. There was a proposal around users paying the fees essentially on the source chain moving. Not sure if this is actually used anywhere. I haven't heard anything about it for a while, but I'm wondering if you guys are thinking about solutions to this, because obviously you'll have a lot of relaying happening, right, on Union Bridge.
Yeah. To be honest, like I alluded to that solution initially, like public goods is just really fragile. And it might work for the first 6 months when people are excited about a new chain, but 3 years down the line, it always becomes an issue, and relayers have to beg for basically new funding, new grants, etc., to keep it up and running. So the most resilient system here is, I think, to be honest, a very simple one. Users pay fees in whatever token they want. Relayers can basically observe, does it make sense with the current gas prices, with the current fees right now to execute this or not? Kind of goes into a massive funnel of order flow, and relayers settle this across different chains, right? With Union, we have taken the position, like we batch transactions in single packets on Ethereum, and that makes the cost significantly cheaper to operate for relaying. Very much optimized on that, but that gets you the best system. And then as a relayer as well, you basically make back your investment immediately, instead of needing to go back a month later to show this is how much you've relayed, can we get new funding?
Right.
Basically the software, for that very packet, already knows we're going to make profit on this.
Right. So that's an important decision. Plus, all the fees are pooled for that batch, right? For that relayer, they're getting each transaction.
Yeah, exactly. And one could, for example, imagine on Ethereum a relayer actually relaying through a separate smart contract that then receives their portion of the fee and immediately sells that off on Uniswap, right? And immediately recuperates their investment, increases their Ethereum balance, and then it's a very simple calculation. Like, after submitting this packet, do I have more ETH or less ETH? If you have more ETH, you just submit it immediately.
Right. Yeah, makes sense. That's still challenging with the gas costs on L1 now. I mean, those going to be high value packets. How many transactions do you guys batch from Ethereum going, to this? Like, what would be the typical size?
Yeah, so that just depends on traffic. There's two things right now. Our current circuit right now can batch an unlimited amount, and per packet that you submit, it's about 50k to prove the inclusion, and then, I don't know, an ERC20 cost is 28k, I think, for an ERC20 transfer, so pay about 80 to 90k in gas, and that's already cheaper than what you have at layer 0, which is at 110k gas. But the cost for verifying the light client and doing the client update, it's about 400k gas. So you need approximately 6 to 8 transfers in a batch for it to be cheaper than existing bridge providers. And then like you start recuperating your costs compared to them. Users pay about like $20 to $25 in fees. We're working on a separate circuit right now that does the packet inclusions with the light client update. Then you just pay 400k gas in total and no longer that 80k gas per extra transfer. And then we batch about 16 packets per update here. That gets you, like, to be honest, as a relayer, a really competitive pricing. Then the only real protocol that is cheaper at the moment in gas cost is across, but you start beating layer 0, XLR, and wormhole in gas cost for end users. And to be honest, that's the game with relaying, right? Like, the less gas cost you pay, the more of the fee you can take yourself, and the more you want to run this.
So, what parts of the protocol, are you thinking of evolving more? Like, in essence, like, where's the team focused now? Like, you've built out a bunch of stuff. I mean, that's a lot of tech. Like we've gone through right here. Is there anything you guys are focusing on now that you feel is like, oh, that's got to be improved before we hit mainnet or before we integrate this?
Yeah, so Circuit and ZK were finished and nearly done with the audit right now by Spearbit. Our main focus right now is actually new networks. So we have a really solid tech stack right now that works with existing ecosystems. There's obviously always dots on the I's and extra things to handle, especially since we are basically targeting the latest releases of the Cosmos SDK. So we're working with many teams out there to make sure that they're able to support us as well. I'm very excited about, to be honest, kind of the boom in L2s that we're seeing. I think the modular stack kind of allowed people to create these chimeras of new technologies, right? Like combine the Move VM with Snowman, Consensus, etc. And so there's going to be a lot of new ecosystems that we can support and target where we have a lot of hard tech work to do. That's going to probably dominate our next year and a half in work. I think the final iteration for Union, if you're doing ZK bridging, is always proof aggregation and proof singularity. So you're in a world of many ZKPs, you go to a world of a singular ZKP. My opinion right now is that the speed isn't compelling enough to do so. If it's going to take you an hour to bridge, then your UX isn't going to be good enough to actually warrant competing against more centralized bridge providers. So although ZK is already there for a lot of use cases, it's not there yet for proof singularity or aggregation.
Right. How would you think about positioning Union or comparing it to other tech like XLR or Cross?
Yeah, so I really like XLR's design, by the way. I think out of kind of all legacy intro protocols that we saw like last cycle rise, I think they've got one of the most solid implementations, but it is fundamentally still multi-sig, but spread across a large number of holders. The downside of this approach is that each of the validators needs to run a full node of the networks they support, and that doesn't scale well. Yeah, like if you work towards a world of 10,000 Cosmos chains, then like an XLR validator will be, it doesn't scale.
So right now I think it's 14, 15 RPC nodes each of the providers runs. They need to be connected and voting on all the smart contracts and all target chains, right, for the transfers.
Yeah. So it's difficult and doesn't scale very well. And if you want to make it scale better, you reduce the amount of RPC nodes you need, but now the security goes down because effectively the RPC nodes are the multi-sig holders. They are the sources of truth. Then you have across, and across from a protocol perspective is very simple. Basically, the contract just emits one event that says someone wants to get like 12 USDC on this chain, and you hope that some market maker like in the Web2 world picks this up and settles this for you. And if that happens, they use a slower oracle to pay back that market maker on the origin chain. From a gas perspective, this is quite efficient because just emitting an event and not doing anything with it works very well. From a security perspective, it's less efficient because there's no mechanisms to force the oracle to pay the market maker, or if no market maker picks it up, to force the oracle to return the funds to you. So from like a pure censorship resistance perspective or centralization perspective, it's not as good and can really only handle asset transfers. It can do message passing or interchain accounts. Plus market makers need to have liquidity available. And then we have, of course, what Union does, which is based on zero-knowledge light clients. That has the best security properties. Basically, makes every chain a roll-up that settles on another chain. And the downside is the tech that you need to build is far more complex. So you spend a year doing R&D to build all of this out before you have your first iteration of a product. And I think 3 years ago, we were all a bit over-optimistic about ZK tech and how fast it would arrive, a little bit like nuclear fusion. Right now, a lot of it is arriving and being very applicable, but we definitely went through a phase where proof generation was 20 minutes instead of a few seconds, right? And where a lot of this took exceptionally long times, and so for your end UX, ZK used to be a lot worse.
But you guys feel that that trend is sort of going in the right direction and that you guys are going to be competitive on speed?
Yeah, so for us right now, right, like proving time is about 7 seconds. That already like is competitive enough that as a user you don't really notice this anymore. And we're like about to reach kind of the era of common GPU acceleration for proof generation, as well as FPGAs and ASICs. And with those, this really is going to go down to milliseconds.
So what sort of infrastructure operators or what participants do you have on the operational side of Union, right? So there's relayers obviously running Voyager, that's one. Are those ideally also running Galois? So you mentioned they might be separate or not. Like, so what's your mental map of who's running this thing?
Yeah, so I always think like, although technically they're separated out, from a market perspective, I don't think it makes a lot of sense to run them separately because you lose a competitive advantage, right? And the whole system is designed around the fastest party can settle these transfers. So to me, I personally think like you run infrastructure, I run my own validators as well. A big machine at Hetzner isn't actually that expensive. And so having these co-located, optimizing for latency here, gets you the highest chance of getting your transfers included and taking that fee. So I do actually think that most of them will be running them the same. Until we see like proving markets like Sysig or Succinct that have like some internal closed source optimization that allows them to generate these proofs significantly faster than the wider community can do, then starts making sense for a relayer to actually point their prover URL to something else.
Right, makes sense. So if you think about, where the blockchain world is moving, like you mentioned, you're excited by the explosion of L2s. What do you see, 3-4 years down the line? How are you preparing for this with Union?
Yeah. So the world I want to see is a world of more DYDXs, right? Where you can take a successful project, put it in its own state machine, can be an app chain or an L2, but basically control your own block space. Because as we see right now, that leads to a very good product, a very good value accrual for the token holders. It's not a good use case for like general purpose L2s or L1s because they lose like 200 million in revenue a year by apps doing that. But for the apps and the end users, this is much better. And if you start looking at what the blockers are for doing this for the wider application space itself, I think what people realize is it's the lack of composability when you go to your own chain or your own state machine, right? If you're on Ethereum or Solana, it's trivial to build a DEX aggregator, right? Those are very small smart contracts. Building a DEX aggregator across Cosmos is, of course, extremely hard and requires like skip protocol, IBC relaying infrastructure to accomplish that. It's like a 6-month to 12-month endeavor to do this over a 1 week hackathon. And so at least for Union, like what my focus is, how do we get like this composability in the modular stack, in the horizontally scaled stack, as good as we see on Solana or Ethereum, right? Can we get almost the same properties with IBC as we do with the smart contract to smart contract call? There are of course some limitations, right? You can never do this synchronously, right? It's always going to be an asynchronous call. But to be honest, like right now, asynchronous computing across blockchains is definitely a lot harder than making API calls in a Web2 app. So we do have a lot of space that we still need to go for this becomes possible. And that is kind of like the world I alluded to, the 10,000 L2s. That's not 10,000 general purpose L2s that people deploy smart contracts on. That's 10,000 apps with a specific focus, a tailored UX that they are in full control of, and where we kind of have the maximal like UX available that rely on each other. It always hurts me a lot to see people build out new ecosystems in isolation, right? Like they always do the same, where they have a VM And now they have a DEX, a lending protocol, and they're kind of forks of pre-existing ones. They're reskinned, and now you have a new ecosystem. I would like to see people like use cross-chain but reuse existing ecosystems, right? I think that's probably where the future where we're heading towards with modular, and the most powerful future as well.
Yeah, that sounds like a really exciting future for you guys to hit.
Well, fingers crossed, but everything seems to be going well.
I guess that's a good place to end the podcast. Well, thanks very much for coming on, Karel. That was super instructive.
Thank you very much for having me.